Greetings from my recording studio located on the dock at beautiful Monterey Bay, California. And welcome to this presentation on the characteristics of linear relationships. This is the second in the series. And in this case, we're going to be looking at the constant rate of change that we will determine from the graph rather than from a table of data. For now, linear equations that we're working with take this form. B plus or minus mx equals y. And this is called the slope-intercept form. Remember that B is going to be on the y-axis. M is called the slope or the rate of change. And remember that the rate of change, M, is defined as the change in y divided by the change in x. We've seen that we can easily determine the rate of change from a table of data by drawing in some brackets between 2 points and then determining the distance between the 2 points. The distance, for example, between 1 and 4 is 3, and the distance between 2 and 4 is 2. Both of those are increasing, right? So this becomes plus 3 to go from 1 to 4, and plus 2 to go from 2 to 4. Then we just ratio those two values. Delta y is 3, delta x is 2, and that gives us that the rate of change is 3 divided by 2. Now, since the graph is just another representation of the same function, we should be able to get the rate of change from the graph itself. That's really easy to do. I like to draw in these, what I call slope triangles. That just keeps me organized, gives me a visual of what's going on. And then we look at this first point up here. It goes between y values of 10 and 7. That's going to be 3. And it goes from x values of 7 to 9. And that's my value of 2, just like we got from the table. That should be the same for every one of the slope triangles, because this is a linear relationship and the rate of change does not differ from any 2 points on the graph. So we go from a y value of 4 to a y value of 7. That's going to be an increase of 2. And we go from an x value of 4 to 6. And that's going to be 2. And if you do it for the next one, you'll get exactly the same result. It doesn't make any difference where you draw the slope triangle. It's going to be 3 over 2. Just a reminder, this is an increasing function. We know that from 2 ways. One, from determining the rate of change is positive, and by looking at the graph slopes up and to the right. Both of those indicate that this is an increasing function. This is the first time that we've looked at a decreasing function. A couple of things to notice is that a decreasing function slopes down and to the right, and it has a negative rate of change. Let's see how we get that from the graph. This point has a y value of 8, and we drop down to a y value of 5, and that will be a negative 3. And then this point is at x equals negative 4, and it goes over to negative 2. That's an increase of positive 2. And then we just ratio the delta y, which is negative 3, and divide that by the change in x. That's going to be positive 2. We can do the same thing down here at the bottom of the graph. This is going to be negative 3 over 2. Now, if we had drawn the slope triangle like this, we go from this point, y equals negative 7, to y equals negative 4. That's an increase of 3. And then whenever we go from x equals 6 to x equals 4, that's negative 2. So we get the negative slope in both cases, regardless of how we draw the slope triangle. Now here's one for you to do. Go ahead and pause the video and determine what the slope is. Just remember that we know it's an increasing function because it slopes up and to the right, and because it's an increasing function, it has a positive rate of change. I'll go ahead and do the solution now. I'm going to draw in the slope triangle. From 6 to 9 on the x-axis is 3, and then from 5 on the y-axis to 10 on the y-axis is an increase of 5. So my rate of change is the change in y divided by the change in x gives us 5/3. This is a decreasing function. Notice that it slopes down and to the right, and that whenever we draw our slope triangles and determine the rate of change, it will be negative. You go ahead and do that. Pause the video. I'll do the solution now. I'll draw a slope triangle between these 2 points. Let's do the vertical distance first. This point is 8. We come down to 4 on the y-axis. That's going to be a change of negative 4. And then on the x-axis, we go from negative 7 to negative 2. That's going to be an increase of 5. So our slope is going to be negative 4 over 5. Remember, we could have drawn the slope triangle different and got 4 over -5. It makes no difference. At the end of the day, it's just going to be -4 over 5. That wraps it up for this presentation. And at the end of the day, there's only one thing left to say, and that is that's all, folks. Thanks for watching. Thanks for learning. Stay safe. Con cuidado.